So on the stage right now is Youping, Elijah Willis, Brent East, and Robert McLaughlin. It was a late addition. We did lose one panelist, unfortunately, but I think we picked up a good alternative, so I'm pretty excited. So we do have a set of prepared questions, but I definitely want to get some, feel free for audience members to jump in, right? We want to make sure you guys are involved and ask questions that are related to your guys' situation, right? And it's all focused on getting additive manufacturing implemented into your companies, your industry. So please feel free to jump in at any time, okay? So I'm gonna start off with canned question number one. And it's, there are those within a company that are not open and receptive to additive manufacturing technology. How do we overcome that lack of technology acceptance? Whoever wants to jump in.
The one thing that we've found, I guess as far as our marketplace goes, the departments within the factory that are interested have, basically kind of forged ahead, getting some parts to us, getting samples, coming in for a visit, and getting something tangible they can take back to the others within the company, make their presentation more real life and not just theoretical, and that seemed to really help them advance along at that point.
I'm a little lucky in the sense that my entire organization is built around additive manufacturing. So, but one thing I'd say that as a business development guy going into customers and basically having to kind of sell the same idea is, the more established you are from a data perspective, and having things vetted by third parties. Having your technology out in the market, it kind of brings validity to what you're selling from an idea perspective. So it really helps a lot.
I think if you go back looking for the additive manufacturing, especially for metals, and you realize the technology is ahead of the science. And so what happened is there's a push for crossover from plastic to metals, but the metal has a different knowledge base. The science was totally different than the plastic. And if you look at this, how the things evolved, I'll give you an example of people sticking with this direct metal laser sintering. This term was incorrect, and but the reason for it being incorrect was originally this technology was based on the plastic using CO2 lasers, and with little powers and different wavelengths cannot fully melt powder, metal powder. So what happened is that when this crossover happened, and during the same time, a fiber laser has been very mature, and so when they adopt the fiber laser being with a 1 micron wavelength and highly efficient for melting metals, they didn't want to change, right? There's one reason they didn't want to change the term is it has to do something with welding, and welding always has a bad rap and bad name about it. And the reason I say this is my entire career background was in welding. I'm a welding metallurgist. And so if they had pushed forward, says this is a precision welding printers, they probably don't have today's sales. So the thing is, I had this shocking news when Marshall Space Flight Center prints some metal parts, and the NASA administrator came see, says, well, this is great. We don't have to have parts welded anymore. And today we can print these parts without any welding. Well, the fundamental is transient heat, melt, solidifies. It's a welding process. It's not a micro casting. It's not any other things. It's the transient heat, right? And so on that note is the technology ahead of the science. Secondary things is, you know, technology development. I mean, any technology evolution is 3 legs, right? It's know-how, which is technology, know-who, which is the people behind it, and know-why, the science, right? Today, you can put all the best practice companies together, says, well, you guys print this metal together pretty well, and you put those guys together, and you ask them for the best practice. What you will find is the overlapping area certainly is getting a lot more, but there's certain things. One company will say, this is a deadly thing. You cannot do that. The other companies strive onto it. So this is the reason I did this. So for number of the suppliers we've been, you know, working with, we put them together, says, well, you know, let's just compare notes. Of course, nobody wants to compare notes, but certain things they share, you would find out the best practice is far from perfection. So I think the things it's really a good trend where with you know, the government investment and all the societies putting a lot of emphasis on this, and SMC being one of them greatly pushing this technology forward. And there's enough research fund to find all kind of researchers associated with additive manufacturing. And these things will come to, you know, the reality. But currently, the technology is ahead of the science.
For additive manufacturing, I have a buddy who is a metallurgist at University of San Diego, UC San Diego, and he always says, Robert, I can make a dog bone of any material. We can make samples of any material. The issue is, how do you make materials that can be actually commercially and reliably produced? And that is an issue. So coming from Stratasys, we do make printers. And when it comes to additive manufacturing, if I'm looking at the sense of making parts, we can do that. We can do that with the materials we've created so far. But there's also additive manufacturing, which includes tooling, jigs, and fixtures, and things to help the manufacturing process, but not necessarily the final part. Maybe it's a sacrificial part to make a composite layup. So I think one of the challenges we have when people don't understand additive manufacturing, some people want to just print the part out of whatever material and just disregard the current process of how you do it. But that's a huge leap forward to go from how I do it today in metal, and then I just want to print it. So in a lot of ways, one of the things we're spending a lot of time is exposing people and companies to ways to use 3D printing and additive manufacturing to start by helping with manufacturing aids. Even if it's a drill guide, how you would make a drill guide today if you had to make one out of sheet metal and tubes, and it's long, it's laborious, you go to outside machine shops. So we're showing people how you can actually print those things. It's about exposure. It's just exposing ideas. It's exposing cool models to people who, when you see them, then you go, I could use that in our factory. I could do this on the floor. In fact, some of the best ideas we as a company see is when we go back to our customers and they, the users, have come back and want to show us all the ideas they've come up with about this is what we've done with 3D printing, and you're like blown away. So it's really sharing, and I think that's one of the things we're at a point with additive manufacturing is we have to have more people willing to share what they're doing so that others can benefit across companies.
Thank you. That's pretty good. Kind of related to that, so it definitely seems as if there's some that are aware of the technology and some that are not. You know, how do we educate those within a company? Is it as simple as fabricating a bunch of parts and samples, or is it, you know, is it more than that, right? So,
I'll start just by my opinion is, again, from an exposure perspective. For years, again, we sell printers and we sell a different line. We sell FDM and Polyjet, and they're good for certain things. There are others that are direct metal, and they're graded metal. We used to, for years, we were trying to prove to people that you could print stuff. So we had my boss likes to call it the bake sale of parts. You had a table, and it had, you know, thousands of little cool parts that were printed and had colors, and people thought it was cool. Today, I'm all about, let's make big parts that tell a story about how people are actually using it. So it is getting back to just exposure. That's my idea on how we help others see the benefit.
I think the trainings for adoption of the additive manufacturing, the process is really slow. I mean, it takes a long time to observe it. But the thing is that the biggest payback is to enable the designer to design the parts, right? Right now, so we deal with two problems, and so we have a new Rocketdyne where they design the additive manufacturing methodologies, and so it's really easy for process engineers just put on a build plate and print themselves. The biggest challenge is we have some heritage parts like the space shuttle main engine parts, and today they're using that, and the parts was never designed for additive manufacturing. So be able to produce that parts using additive process, it's extremely challenging. And so there's a lot of know-how be able to enable that happens. And I think a lot of times because the company is compartmentalized so far, and the cross-pollination hasn't occurred that much. And it's only a small group of people dealing with this on the daily life. They know how to make that happen. And so I think eventually it would be some training courses developed.
Thank you.
I think a couple of different approaches that companies can take. At OPM specifically, what we do is we try to understand the issues that our customers are dealing with manufacturing parts in specific applications, and we spend a lot of time doing research on not only how we're going to provide value to their supply chain, but also kind of dealing with the day-to-day type of issues that design engineers and manufacturing engineers and our customers are dealing with. Because one thing I've talked to a lot of different designers and manufacturing engineers, and while in some companies they have the ability to worry about cost and lead time, some organizations are large enough to where they're just worried about if their part's going to work or not. And I think if you kind of go in and address those concerns and issues, and have a team specifically working on educating them and working with them to incorporate design and engineering for additive, that's going to allow you to kind of get a lot of attention into the right group.
I think coming from a little bit different piece of machinery, it's a little bit different from my side. And kind of what we're dealing with right now with the large scale type stuff, additive manufacturing is kind of the buzzword right now. There is a lot of excitement about it. But as you were saying, it's not just printing a table full of trinkets and everybody excited about the fancy parts or colors. It's finding the stuff that really can help out in the industry, whether it be as simple as a holding fixture or a layup tool or whatever it might be. I think it was touched on several times throughout the presentations that this isn't really going to replace a lot of manufacturing as we know it today. It's going to aid that, and it's going to help speed up the process overall for all that. And I think that's the key is getting those types of parts out there and letting people see how they're actually helping the overall process in the industry. Not necessarily, hey, but we grew this part and it wasn't quite as fast as what we typically do, or it's not the right process. It's showing them how to get that part into production the right way quicker.
Okay. So kind of related to the first two questions, something that we've heard, and when I was just walking around talking to people, this actually came up a couple of times, but one of the most difficult challenges is educating upper management, right? So sometimes they could be, they don't want to know details, right? So they, how do you educate them on the advantage of additive manufacturing? Especially how do you get them to invest in resources and funding for the technology?
That's a tough one. Nobody likes change, especially if somebody's been doing the same thing forever. And again, I think it just it all kind of correlates back into the first two responses. It's proving out the return on investment, the changes of I've heard additive manufacturing referred to as the third industrial revolution. It's going to change the entire industry. But I think a lot of that just has to tie back to proving to industry the value added that is actually in additive manufacturing. It's not just making prototypes or those types of things. It's thinking outside the box. It's finding ways to utilize it for faster production.
I would definitely agree with Brent in saying that I think one thing that the industry as a whole is going to have to do is kind of get past the trinket or ideas where everybody is gonna have a printer in their house. And I remember an executive some time ago saying that somebody in the audience asked the question if he thought that everybody was going to have a printer in their house, and he said no, they're going to have a printer in every room. And I think that idea is, from a consumer perspective, you can build a part, from a model. It looks great, it's cool, but you're going to stick it in your junk drawer and never look at it again. So I think it's up to companies like us sitting here on the stage to create a really mature supply chain and create value that is going to be looked at differently than 3D printing of trinkets, and start to kind of have, when somebody hears 3D printing, they think about a functional part, something that's going to work for an application, not necessarily just going to look like a shape that was modeled on a PC.
I think for us in the rocket business, we really don't have to educate the upper management, and its competition teaches them what they have to do. And so, especially you have those billionaires enter into this market with their own rocket business, and so we were not the first one to adapt this process. I think SpaceX was the first one bought a machine on their own, but we quickly learned the things, and we put a significant resource behind it, and we make it into reality, and by printing parts on a mission critical component and many space flight level. So that demonstrate this is the future. And from there on, I mean, the metal parts in front of it, those kind of parts will just, as example by themselves. It's previously, how do you do this? It's multi-component, joining together, welding together, brazing together, right? Today, you can print monolithically one part. And so if you enable the design communities, and because previously a lot of rocket engines were manufactured with multiple components, taking each of the alloys advantages, right? The liners is typically high conductivity coppers, and today with the flexibility of additive manufacturing, you can inject the coolings in a different zone, different regions. You can manipulate all of those. So monolithically, one alloy was able to do multiple alloys function. And so we don't have to really teach those executives. Executives previously, like 10 years ago, maybe 6 years ago, they were on the order lines, right? With the GEs printing the things and applying things, and so a lot of times people still, you will still have a middle management skeptical about it. They said, well, they did a study when they was UCSB, and they said, well, the powder, you'll never be able to print flawless powder material. And what we're seeing is, well, we don't have to. Look at the industry's trend. GE is doing it, everybody else is doing it, right? But the executive, this is a wonder drug. And how good this is I think a lot of presentations here talk about 80% weight savings, more than 80% of schedule savings. And so the things is, to us, become a double-edged sword. It's when you have a performance enhancement, 80%, weight saving 80%, schedule saving 80%. So what happened is compounding those factors, right? You literally producing the same part or better parts at small fraction of the original cost. And the only problem we experienced was on the hypersonics program. And it's the first one, the US government was willing to give us a large sum of money to do it. Once we mature the 3D printings, they order the same amount, but the overall cost reduced from $1 million to a few $1,000s. But now, how do you support the people? So we're facing like, well, gee, what do we do? If we don't attract more customers, or the customer doesn't order more, we're gonna lay off people.
Yeah. I'm going to jump in there really quick, Robert, before you get in there. But we have very similar experience to Youping's. Our executives, all they hear is return on investment, the cost, the schedule savings, and the performance, right? The weight loss, and they're sold. I mean, that's what they have to hear. They don't really care about the microstructure, the technology being used. Those key components, they hear that, they're in.
I would say, though, the challenge is they're excited about it, and it's the buzzword. I used another term here, the miracle drug or the wonder drug, right? So a new wonder drug. I think one of the challenges that we have is setting the right expectations for those executives.
Yes.
Right? They come in and say, they hear all these great claims, they see this. I think, again, it gets back to, I think, Brent, what you said is it's about use cases, and it's about process, and it's about ROI. But we have to be very careful to set their expectations on a process. We're going to help improve a process. When you go from design to delivery of a product, whatever it is, whether it's a rocket, whether it's an iPhone, whatever it is, there are thousands of processes in that design and manufacture cycle. Additive manufacturing is going to become part of some of those processes. Subtractive manufacturing is going to be so. And it's not going to be the panacea of schedule reduction of everything, but it is going to help different processes. And when you impact different processes, you are reducing the risk of missing schedule. I think that's what most executives actually fear, is missing schedule. But we do have to work on letting them see and knowing the expectations of, in this process, we used additive manufacturing, and it gave us this time savings, this cost, this weight savings maybe, but we really have to make sure that they don't believe it's that easy, because it's not. It isn't easy. We're barely scratching the applications. We're barely scratching the materials that are required. Today, the additive manufacturing industry is still very infant. We've been around for 30 years, and so we're really, at least people believe we can print things. No one doubts that anymore. My mom knows we can print stuff, right? But printing it effectively, printing it for the right materials and characteristics, setting those expectations, it's up to the groups like us to expose people to what we're doing. And that's mine.
Thank you. That's good. Any questions from the floor yet?
What are your expectations on how information will be flowed down from OEMs, especially with regards to flight critical type parts? We don't do any design ourselves, but we manufacture a lot of parts, and we know that reducing weight is key in aerospace and in space, and we believe eventually we'll have parts to make. How will that be flowed down by the machine type, by the material type, by the process in which the material is bound? I mean, I guess there's a lot of questions to deal with that.
Actually, I'll address that very quickly from a Stratasys perspective, because we do believe that's an issue. So one, there is the question of design for additive, and you guys have touched on that. If the mechanical engineers aren't educated on how to design for, I mean, we used to worry about design for manufacture, don't put an undercut. Now the new term is design for additive. Where would you use a lattice structure if you could, etc. But it is going to come down to a point where the large aerospace OEMs of the world, or the automotive, they may actually say, we're going to actually design for additive, we're going to come up with a part, we're going to expect it to be of this material, and if you're in that supply chain, we're currently working with the FAA on certification on a specific machine with a specific material that would be then certified by the FAA. So the good news is those companies don't have to go through and spend all that money. So from an OEM perspective, we're trying to make those things easier on you in the supply chain. If the OEM specs out that on a drawing, as long as you have that machine, you could actually create it. So we understand it's a challenge. We're just barely touching it. There's a lot of ways to go, but it is an understood issue in the industry.
For the metal side, I think there's still disparities between what process to be used. And so if your prime is set on certain machines, they still demand you to use the same machine, same powders, and producing same parts. And so if you only a manufacturer like the order takers, it is tough. You have to follow them. If you're the order makers and you own the parts, and then you have the liberty to choose the best process for your own. Like the process, I think in the near future would be like, it would be a machine independent, and it doesn't care what machines do you use. But just be careful, because the scan strategy do produce different microstructures, so that has to be aware. And many about 3 years ago, I had this conversation with Air Force. Air Force said, "Oh, this is great. We can reduce legacy hardwares, because we have warehouse full of the hardwares supporting B-50, B-52." He said, "Now we can get rid of this." And in the process implementing this, so this is pretty ironical, right? They said, "Well, we're going to freeze this process on the certain machines, on certain software, on certain things can produce this, because now we believe we nailed it on this machine, on this software." So the question is, well, now you don't have a legacy of the hardware stored in the warehouse, but you're going to end it up with a legacy software, legacy machines, right? Because the machine evolution is really quick right now. The software evolution is even quicker. And so I think, yeah, you lock yourself in a different box, but that box doesn't really help. And I think the science is really needed to push these technologies to be widely adaptable. And so it shouldn't be, this part can only print from EOS machine, that part can only print on the SM Solutions machine. And it should be universally understood.
I absolutely agree. I think we've gone through qualification with a couple of primes, and one thing we've seen is starting out from a spec side of things, that we kind of get boxed into a corner and start going through a qualification, and as the data is generated and tested and presented, I think what we've seen at OPM anyway is we start to, the spec that ultimately gets released is looser than what was originally written, just because if you take a point spec approach and really specify things like mechanical strength, density, dimensional tolerances and things like that, as opposed to putting requirements on things like specific machines, material suppliers, even building parameters. You need to be able to, in a production environment, account for machine to machine, material supplier to material supplier, and all those types of things. So I think the more, I guess the long and the short of it is, the more educated OEMs become in this technology, the easier that will be for things like specs to get flowed down. And I think ultimately what's going to happen is companies like us represented here on the stage are going to have an easier time going through quals and things like that.
I agree with all of that. I think some of it was touched on earlier, just the sharing between parties. Whether it be you guys sharing information back to us once you receive parts, do your testing, find out what real life is versus what's requested. It's a combination of that, material suppliers, sharing information, trying to make it more commonality between one machine to the next, or going from one process to the next. But overall, with everything still being in the infancy that it is, unfortunately, what I see on a day-to-day basis are a lot of people that they want to keep all that information to themselves. They don't want to share with anybody because they feel like they're getting the leg up on the guy next door. So it's tough sometimes even for us, like you said, the more educated us OEMs can become, the more we can help you. Sometimes just getting that information back to the OEM is a little bit of a struggle. So it's all a balancing act right now, I think, at this point.
Very good. Any other questions from the floor? Nope. Go ahead.
I'm curious, I was involved with proclamation back in the 80s, right? And so in the beginning of the networking proclamation, a lot of these issues very similar to additive manufacturing today. So could you comment on how you see progress has been made over the last 10 years? There's always the road that we have not traveled, right? And
right.
There is the road that we have passed, right? So kind of like from your perspective, been in here for a long, long time, where are we in this spectrum?
There's still a lot of growth to happen. I think each one of us kind of represent a different sector of the market up here. One area that I'm seeing in my area that seems to really be the driving factor of what's advancing, what's coming, are the material suppliers. As far as the polymers go, they're trying to introduce more and more things that are, conclusive to doing additive manufacturing and successful for tooling or successful for, autoclave ready. Those guys seem to be the real driving factor at this point. I mean, as far as our machine goes, we can extrude, and grow any type of material they present to us. It's those guys figuring out the combinations of the right stuff to give the right end result. I think that's growing in leaps and bounds right now, and those guys are putting a big push on that. As that grows, the entire market grows.
Yeah, I'd also add that I think as a whole, the industry is going in the right direction from the perspective of you've got a lot of not just interest from customers, but you've got a lot of companies like Stratasys, 3D Systems, EOS, the material suppliers. Everybody's really focused on kind of maturing the technology and getting it to a point where we're ready for engineered parts. Providing structural parts, providing repeatable, reproducible parts. And actually looking at this from the perspective of true manufacturing and not necessarily just making near net shapes and things like that. So, I'd say, OPM has benefited from organizations such as American Makes. That was definitely extremely helpful to the industry as a whole, putting forth a lot of focus and attention on additive. And in the last 10 years, it's really come a long way. I'd say in the last 5, it's come a lot further. And I'm definitely looking forward to seeing how it's going to progress in the next 5.
I think definitely the past 10 years, people seeing the benefit of the additive manufacturing, and also they treated it as, a lot of companies treated it as their core competencies. So once you being categorized as the core competencies, and there's a lot of things they don't want to share. And this including the OEM. When I say OEM, means the manufacturer of the machines. And so I think once the science catch up to those things, it would become common knowledge. But so far, you don't see GE share anything more than necessary, and you don't see those primes share those things. They only share, they had the things fly. They only tell you save their monies, and But as far as detailed technology, in the past 10 years, it's absolutely, anything they say advantages, they acquired them. They, got them up as internal resources. So I think with the science caught up on this, and it would become a common knowledge. And the past 10 years has been a highly competitive process, and you see Pravani and GE, Honeywell's, all goes to the same, same additive shop to producing parts, and but they're highly, proprietary, and so that's the things. That's why additive engineers are commanding a lot more high premiums to the regular other engineers. So, but I think eventually it would be a common knowledge, especially with a lot of those societies like Society of Manufacturing Engineers getting involved, training other people, and spreading this knowledge out. And I think 4 years ago, I attended one of this additive tutorial. We were doing this in-house. We did a lot of work, and we just didn't know outside what they do. When they charge $4,000 for a tutorial, you go in there, and they only pitch you. The only pitch you hear was, sales. They're trying to sell you something. Right? I said, well, why do you call this a tutorial? And this is, you really want to educate people on this, right? And this is at the end of this entire session, and the organizer is bringing me over to the corner. Are you kidding me? This is everything they keep into their chest. They're not going to tell you anything more than that. Well, for $4,000, and it's really unfair to categorize this as a tutorial. It's basically sales pitch, and so that's the reality.
I'll say in the last 10 years. So I think that the metal, I think from a perspective of how we actually process and create and grow metal, I think really has advanced. When it comes to plastics and polymers, I think that technology has been around a lot, and what's been exciting in that area has been the advancements in material and what we can do with different materials. And if everybody could actually just survive on PLA, we'd all be really happy. But the reality is we are required to provide highly engineered parts out of highly engineered materials that have to fit certain specs. And one of the questions that I know is on your sheet is about the cost of additive manufacturing and the cost of materials, and why is it so expensive? Well, right now it's so expensive because we have so many, we have requirements for high-grade material that has been made out of metal for now, and we're trying to replace those properties, and we're doing it with a 3D printed part. It's just taking us a while to get there. So the one thing that would drop the cost is if we had more people buying and we'd had more time to research. Qualifying materials, gentlemen, is not trivial, and it's not inexpensive. It takes a lot, and unfortunately our materials are expensive because of that. And they're high quality materials, and whether my machine is in India, Indonesia, or Indiana, it has to work. in all three places. It can't be just regional. It has to work globally. And when we ship a canister from Israel, we need to know all the way back to where that material came from and those raw materials came from. So those are the types of things that, one, we've advanced in metals, and I think we've advanced a lot in materials, but I think materials in the next 10 years is where we're going to continue to really, I don't think you're going to find a new FDM or a new Polyjet or a new SLS or a new, kudos to HP with the multi-jet. That's a great new technology, but I mean, it's similar to others, but I don't think we're going to see a huge different way to grow it from I don't think we're going to see a great new technology. I think we're going to take all these awesome technologies and improve on them with materials.
That's good. Sure.
Would you comment on inspection? Because if you design, yes. Would you comment on inspection? Because with these complex parts, and an example, one of the presenter was about channels and so on. So it seemed like the only way you can really inspect that is you have a model, and you measure the behavior of that model. So it's kind of like existing inspection system out there on the floor will not be able to do that today, at least from my perspective.
Are we talking performance inspection or geometric?
Geometric.
Geometric. It's true, you can't run a CMM on an internal. You know what, someone's going to need to probably come up with X-ray scans or some type of way to really run some type of because truly in an additive perspective, you can actually manufacture parts that you could never manufacture on a lathe or on a mill. So you're right. How do you really know that that internal tube that was designed into the additive manufacturing is what it is? I think maybe there's an opportunity there, laser inspection or X-ray inspection that really can truly do it. By the way, we do a lot with medical companies looking to use medical models in DICOM to create then patient-specific models. That's even, I mean, that's just in a body. That's extremely difficult to actually take all that imaging and that scan of point cloud data and come out and have accurate models. I think there's an opportunity there. But I don't think inspection, I think right now we have to do it from a performance perspective. What we expect the performance of the input and the output on the part to be, that's about the only way we can truly do it rather than actually checks in geometry. You guys might have a different idea.
Yeah, I think the inspection side is definitely behind the curve right now. And whether it's a CT scan or any kind of things. And because previously, parts are component, right? You can inspect each of component and then join them together by different methodologies, and the parts on the component level are designed to be inspected. And today, when you stack everything together with the internal things, and now you have to inspect from, 10 inches away from it, it becomes uninspectable. And when you say CT scan is great, but when CT scan cannot find this 20 micron flaws, and where the flaw is, initial flaw size it's about 20 microns, you become an issue. And so a lot of times people are saying using in-process monitoring system to replace the final scan, the final quality assurance inspection. But that's not the way it should be. I mean, there's a purposely separated lines between the producing and inspection, right? Because today I can say, my weld is so good, and I have all the process monitored, and my weld is flawless. And my president used to be saying, well, by God we trust you. Bring me the data. So I said, oh, I have all the data. Oh, by the way, the data doesn't mean your data. The data has to be from the inspector's data. So enable for the additive manufacturing to be on a production level, higher quality, we definitely need the inspections side. And we definitely need somebody to do those, micro CT on a large scale at a different distance from the parts it inspected. And so currently, it is a significant challenge. So by doing in-process monitoring to guarantee a final product is not a fundamental process. It's just the gap failure right now. And so, you know, the inspection side need to be come up with a better knowledge.
I would add that I think this kind of gets back to, you know, identifying appropriate applications for, you know, the limits of the technology as they are today. At OPM, we have quite a few different inspection techniques. So in our biomedical division, we're actually taking CT scans and, well, our distributor is taking the CT scans and designing our medical devices, our implants, and we inspect using a white light scanning system. And basically what that does is it takes a scan of the exterior of the part using point cloud, knitting that together, and then using a software called GeoMagix, will overlay that point cloud over the submitted model, giving you a profile deviation map. And then, you know, in the aerospace side of things, we use X-ray for inspection, but only for porosity. We don't inspect using X-ray for dimensional. What we use laser scanning. Again, it's a point cloud generation scanning. And then the interior structure, what we do is we use basically a magnetic micrometer. Now, it's not going to give you dimensional accuracy from feature to feature, but it will give you a thickness measurement all throughout the component that will allow you to inspect for things like mechanical fidelity and whatnot. So, and then we have a roamer arm that we use for inspecting our machining surfaces and whatnot.
Yeah, I think the only thing really to add to that is, you know, I know we do it, and I heard it touched on several times throughout the presentations here today, is the monitoring of the process as it's going on. All the thermal imaging cameras set up inside the equipment, monitoring the process to ensure that you're getting, you know, proper adhesion, proper, you know, centering and everything throughout the piece, helping to, you know, just aid in the fact that in some aspects there's no good way to do that inspection afterwards.
Okay. So we only have a couple more minutes left. So final quick question. You can keep it as brief as you want. But what is, in your eyes, the biggest hurdle for the implementation of AM fabricated components? I know it's not an easy one, but what do you think it is?
A little bit easier in the realm that we're playing in. You know, with, like I said, you know, in my presentation earlier, you know, our main focus is in the molds and the tooling. So, I mean, it's a fairly easy area to get into without having to have things flight inspected and, you know, further data as far as that goes. It's part of the natural process now. It's just another way of going about it. The main difficulty is, I think we touched on at the beginning of this panel, is just getting the people educated and, you know, getting the right people in place within the organizations to bring this to life.
I think the biggest hurdle is really kind of establishing your organization, your infrastructure, you know, your quality management system, all the way down to things like maintenance, machine maintenance, and all of those kinds of things, and making sure that you're able to address all the different issues that arise with implementation. You know, because with regard to OEMs, the interest is there. I believe that, you know, back to a question some minutes ago, I believe that executives out there, especially on most of the OEMs, they recognize that the things are going to be lighter, they're going to be lower cost, they're going to be delivered faster, but the hurdles that companies that are manufacturing with additive are going to have to climb through are really how to do things repeatable, how to address things like machine-to-machine variation, and you know, as Robert was getting at, kind of building things at different facilities to the same specifications and training and all of that. So I really do believe that the infrastructure is going to be the biggest hurdle for implementation.
I think once you possess the fundamental understanding and you can really make the process robust enough to be able to on a production levels. So I think it's critical to make sure you machines are robustly developed, including your parameters and the environments. And once you achieve that level, and you're able to say, I can repeatedly producing this part within a lot of normal machine variations, then you achieve the production level. Without that, it's always challenging. And I think today, a lot of people are just pushing forward, printing. And what happened is the OEM doesn't have, I mean, my experience excluding the SM solutions, because I only have concept laser machines and EOS machines. We know our parameter is much better than their OEM provided parameters. And so you need to do those homeworks before you can say, okay, well, I'm at that level. And if you don't do that, just using whatever the parameters they provide to you, I don't think you can achieve a repeatable levels. And so once you achieve the process robustness, and you're able to be on a production level.
I guess I'm the last thing between now and the end, okay.
Yep.
Actually, I love what you just said about it. Our customers know more about the applications. And I think one of the things that's going to be a challenge is we as a Stratasys, Kevin's a great engineer, but Kevin doesn't do what most of our people do. And you bring up infrastructure. What we need to do is help our customers develop their own infrastructure, their own knowledge, exposure, however it is, some of it's sharing, because the best ideas we hear come from people who have a machine, they bought it for one reason, and then they said, hey, I could use this for something else. And they come up with a different idea. And they start dialing in what the machine can be used for beyond our expectations. And I think we just need to help foster that within companies that own 3D printers for metal or for plastic or whatever it is. But that's actually what's going to help this move forward. I don't think, from a Stratasys perspective, we make machines. It's going to be the adoption and the design. I mean, I will also say that I think higher level education institutions, having them teach design for additive is a big thing that we need to get. Because right now, there are people who are figuring out, but it's the people who are they just get it. But it isn't as easy as mechanical, I don't want to say mechanical engineering is easy, but it's just different. And you need to find people that either think from a design, a manufacturing engineering and mechanical engineering, how to think differently about additive.
Thank you. Those are pretty good responses. So appreciate it. Let's give them a hand.
Thank you.